next is the OneSec TV broadcasting. OneSec is a mobile terrestrial digital audio, video, and data broadcasting service in Japan, Argentina, Brazil, Chile, and Turkey. Service began experimentally during 2005 and commercially on April 1st, 2006. So today the OneSec system is popular in Japan today. Many of Japanese mobile phones, Japanese mobile phone has ability to receive OneSec, and recently also Canada music system and also portable TV. This shows one of the simple OneSec transmitter. OneSec TV system is not only when disaster prevention applications such as broadcasting is possible. So, next, the proposed function of telecenter as a diffuse institution consider the following the function required to diffuse institution. First one is continuous electricity supply, commercial power, photographic power generation, wind power generation, and storage battery. The second one is gas cooking equipment and gas chilling series. The third one is continuous drinking water supply. Water curing equipment by reserve osmosis method. That's one is status monitor of each equipment by remote control using ICT, the power generation from TV and wind power generation. Energy management of diffusion, taking the level of battery degradation. So EMS, energy management system, is important. EMS data is sent from telecenter to disaster center by high-speed optical network. EMS consists of status monitor of power generation and power storage and power consumption. In addition to EMS, data of battery virtual battery condition watcher system is sent from telecenter to disaster center by high-speed optical network. EMS consists of status monitor of power generation and power storage and power consumption. EMS can provide efficient electrical management such as peak cut and peak shift. And EMS can monitor the status of various power status such as power consumption, and remain battery, and so on, from remote site. And in addition to EMS data, battery condition data is sent to disaster center, battery condition data. So, I'd like to explain the battery condition watcher system. This diagram shows the characteristics of the battery type. The right one axis is time. That's the time. The red line is life of battery, which means that is time to replace the battery. Here, I assume that the remaining capacity will exchange as 80%. Battery life is very greatly depends on the ambient temperature. It's 25 degrees, 30 degrees, 35. Therefore, it is important to know the status of the battery. It's very important. So there is a relation between the internal resistance of batteries and the battery life. This is internal impedance of battery, and this line is capacity, remaining capacity. In this example, the remaining capacity of the battery 80%, 50% like this. About 9 years. In this case, you can change the battery 9 years. Then this line inside of resistance increase twice, 100. It means lifetime of battery. This means you can replace the battery when the battery's internal resistance has become twice. Be able to replace the battery at appropriate time. This is running cost and long-term use in the event of disaster. This is an example of the configuration of battery condition water system. This is a battery, actual battery, and this is sensor in, and this is controller. Digital sensor to measure the voltage, internal resistance, and the temperature. Sensor is installed in every cell. You can replace only the cell, which is the end of service life. This product is easy to install sensor and controller by wireless connection. The controller can store data for an extended period of time. The controller can also be used to send the various alarms, such as voltage, and high voltage alarm, low voltage alarm, high temperature, ambient normal impedance, and also battery life. This is an example installation. Battery condition water system already has many actual installations. For example, this is for data center sensor. Each battery cell has a sensor. So conclusion. We have proposed a new concept of disaster information system and refuge installation using presenter function. Thank you for your attention.
Thank you very much. ministry has established over 1,800 telecenters nationwide. So this concept is really useful, and then this telecenter can act like a kind of a early warning and also a place that it can collect information. Just one thing that I might not agree is that typically telecenters are not connected to the fiber optic. So it's very difficult, not only in Thailand but in other countries. So, but the others, I think that's a very good concept. So, any questions? Any scientists in this room? You may have some questions. If not, okay, thank you very much. Thank you very much. And then we move to the last presentation, of course, not the least. I'd like to invite Mr. Balapatia from Motorola Singapore, and I just came back from Geneva from the World Radio Communication Conference. So he would probably share some outcomes of the WRC as well, but of course he will be making a presentation on the wireless technology standard for emergency communications.